A volcano is a mountain formed from lava and pyroclastic material. And today we're breaking down the three main types of volcanoes: shield volcanoes, cinder cones, and composite or stratovolcanoes. And I need to apologize in advance for the length of this video. Ever since I traveled to Costa Rica at the age of 19 and saw Mount Arenal erupt, I've been completely fascinated by volcanoes, the rocks they produce, the landforms they create, and the powerful geologic processes behind them. Most of my college fieldwork involved studying volcanic rocks and active volcanic systems. Honestly, volcanoes are easily my favorite subject to talk about. I've even caught myself thinking about how much fun it would be to be a volcanic tour guide. So let's dive in. Shield volcanoes have a wide, gentle slope and are primarily found on oceanic crust. Some famous examples include Mauna Loa, Kilauea, the volcanoes of the Canary Islands, Iceland, the Galapagos, and Easter Island. Shield volcanoes erupt basaltic lava, which is has a low silica content, low gas content, and low viscosity. So all of those combined means that it's very fluid and flowy. In places like Hawaii, especially on the lava flows of Kilauea, the lava is only moving about a mile and a half per hour, so it's slow enough to walk away from in most cases. Some of the major types of lava that you would see in a place like Hawaii is pahoehoe, which is smooth and ropey, and a'a, which is jagged and glassy and incredibly sharp. It's actually very difficult to walk on. But we don't want to mistake the slow speed of the shield volcanic lava flows for harmless. In 2018, Kilauea erupted for about 4 months and buried over 700 homes in lava. Shield volcanoes rarely explode violently, but their lava flows can reshape entire communities. Cinder cones, also called scoria cones, typically form toward the end of a magma body's life cycle. They contain much less gas, they develop quickly, and can form in less than a year. One of the most famous examples is Parícutin. It developed in the 1940s. It literally emerged from a cornfield in western Mexico City. Imagine waking up to find a volcano growing up in your backyard. Another example is SP Crater near Flagstaff, Arizona, whose original name is actually Shipot Crater. The homesteader that originally found it thought that it looked like a large chamber pot, and so that's what he named it. People don't necessarily like those types of words on maps, and so history sometimes gets edited. Cinder cones are typically smaller, steeper, and shorter lived than other volcano types, mainly because the magma chambers that feed them start to solidify. But they're powerful reminders of how quickly Earth can change. When people picture a volcano, they're usually imagining a composite volcano, which is also called a stratovolcano. These are the most dangerous and explosive volcanoes on Earth, and every volcano that I've personally visited has been a stratovolcano. These include Mount Arenal in Costa Rica, Mount Etna, Mount Vesuvius, and Stromboli, all in Italy, and Mount Fuji in Japan. Volcanoes like these have higher silica magma, more gases, and higher viscosity, which means that they're kind of sticky, and that magma starts to stick and get stuck in the magmatic vents, and it creates a higher explosive potential. I've witnessed Stromboli repeatedly eject lava bombs the size of cars. I happened to visit Mount Etna when it was during a unusually active period, so it was releasing um, clouds of gases and vapors. And when I saw Mount Fuji and uh, Mount Vesuvius, they had just little clouds of stuff erupting from them. Mount Arenal was probably the coolest. In the late 90s, it was very active, and every night it would have glowing red lava shooting down the slopes. And I was sitting in a hot spring at the base of that volcano and watching the lava coming down the volcano. It was a very cool experience. Stratovolcanoes produce quite a few features. So they have pyroclastic flows, they have ash columns, lava domes, and lahars. Very beautiful, but also very deadly. So domes form when thick, silica-rich rhyolitic lava piles up at the summit of a volcano. The most recent and dramatic example is Mount St. Helens. In 1980, gas pressure built up beneath the solidified rhyolite until the volcano erupted. Another rhyolitic system is Yellowstone. Yellowstone isn't spewing lava, it's releasing gases and heat through geysers and hot springs. And that's actually a good thing. It means that Yellowstone hotspot is not plugged up and it's not going to explode anytime soon. If it were to erupt, the ash and atmospheric debris would trigger global climate effects. So essentially, we would go into nuclear winter because there would be so much ash and debris in the atmosphere that would block sunlight for years until it settled. But right now, the geothermal activity, earthquakes, and all of that is the normal functioning of a volcano. Thanks to Hollywood, we are all likely familiar with the dangers of volcanoes. So first we're going to look at a pyroclastic flow. It's a large cloud of gases, dust, ashes, cinders, and lava bombs moving about 60 miles an hour at a temperature of 1800 degrees Fahrenheit. For reference, metals like magnesium, aluminum, and silver all melt below 1800 degrees Fahrenheit. For particularly explosive volcanoes like Mount St. Helens, the pyroclastic flow reached over 600 miles an hour, which is twice the speed of sound. To put that into perspective, if there was a volcano about 45-minute drive away from your house and it erupted with the same intensity as Mount St. Helens, It would hit your house in 3.5 minutes before you even heard it. Another danger from volcanoes are lahars. When volcanoes start to heat up from beneath and the lava starts rising and gases start emitting and the temperature of the whole volcano starts to rise, glaciers at the tops of volcanoes start to melt. And as those glaciers melt, they create mud flows, which are called lahars. Other types of things that are danger when a volcano erupts includes the ash flow, which rains down like snowflakes, and it's dangerous if you breathe it in because it's essentially made of volcanic rocks. And like I mentioned with Mount Arenal, the lava flows do happen at composite volcanoes, and if they are particularly fast moving, that can be dangerous. Scientists today have many tools that measure the amount of gas and lava that are released on a regular basis, allowing them to predict when volcanoes are going to occur. They also measure the soil temperature and acidity to see if there are changes. In cases like Mount St. Helens, a large bulge started to build on its northern flank about a month before it blew up. There were also an increase of earthquakes about 2 months before the eruption. The earthquakes often indicate that the magma chamber below is filling with magma in such a way that the pressure is building on the existing rocks, which causes earthquakes. With scientists watching the mountain, they put restrictions in place to limit people from entering the area, which significantly limited the death toll. Not to mention, it also erupted on a weekend, which meant that there weren't loggers near the mountain. In particularly explosive eruptions like Mount Mazama 7,000 years ago, the magma chamber partially empties and the weight of the earth above collapses upon itself. Over time, rainwater collects, leaving lakes like Crater Lake in Oregon. The little island on Crater Lake is a cinder cone produced from the last of the magma before the chamber solidified. Crater Lake is about 5 miles across. In comparison, Yellowstone's caldera is so massive that scientists didn't even realize the extent of it until aerial photography was developed. Yellowstone's caldera is about 40 miles wide. Volcanic necks are what remain after an extinct volcano erodes completely, leaving behind the vent that previously fed the volcano. A classic example of a volcanic neck is Devil's Tower in northeastern Wyoming. While Devil's Tower is only about an hour away from the Black Hills, they were formed around the same time, about 55 million years ago. Devil's Tower is much younger than the Black Hills. The Black Hills were formed from an older solidified magma chamber that was being pushed up by underlying magma. That underlying magma released and formed its own vent that led to Devil's Tower. With the Pacific plate subducting under most of its neighboring plates, this produces a string of volcanoes known as the Ring of Fire. This aligns with the earthquake zone in the same area called the Circum-Pacific Belt. Most of the magma that erupts on Earth happens out of sight along divergent plate boundaries. When oceanic crust subducts under either continental or oceanic crust, we get volcanic arcs like the Philippines or the Cascade Mountains of the Pacific Northwest. And when large magma plumes rise, we get hotspots or intraplate volcanoes like the islands of Hawaii and Yellowstone. Volcanoes are important because they build islands and create incredibly fertile soil. They shape our landscape. They are also destructive in that they destroy cities and people's homes and change overall global climate. They're one of the most powerful geologic forces on Earth. And for me, ever since I watched Mount Arenal erupt when I was 19, they've been the reason that I fell in love with geology. If you enjoyed this deep dive into volcanic processes, please make sure that you like and subscribe.